Hey, this is Mr. Hendrickson, and this is your Conceptual Physics Experimental Design Pre-Lab. The purpose of this tutorial is to show you how to design an experiment and also follow through with the data analysis, graphing, and conclusions. The big idea here is that there's no one perfect method for experimental design, but that it all must in fact be systematic. There must be a method. Before you do anything, obviously you need to figure out what's the problem you're trying to solve. What are you trying to discover? In doing so, you'll probably have some variables that you're going to want to examine. Typically, the independent variable is the item that you are choosing to change within your experiment. The dependent variable is usually what you're going to look at that changes as a result of what you change. Any other variable in your experiment must be controlled. In other words, it cannot change from trial to trial, but must always be the same. Once you've figured out what your problem is and what your independent and dependent variables are, it's time to write a purpose or hypothesis. Hypothesis is typically a statement in the if-then format. So you'd say, if this occurs, then I would expect this to happen. If I change this, then this will occur as a result. Some labs might require you to write a purpose, and this is simply a statement of the goal of the lab. What was the point of doing the lab? What was the purpose of you actually doing this lab? Once you've written your hypothesis or purpose, it's time to determine a procedure. These are the series of steps that you're going to carry out in order to examine your dependent and independent variables and find a connection between the two. In order to do so, you need a numbered set of steps. Step 1, do this. Step 2, do this. Step 3, so on and so forth. All of your steps should be in command language, so specifically telling someone to do these steps. Step 1, weigh out this amount. Step 2, measure the volume of this item. Okay, it also needs to be very detailed. So in other words, what equipment are you using? What size of equipment are you using? What should you record? Are there any safety measures you need to take or need to examine? And also, you need to account for multiple trials. Good experiments, good experimental design involves more than one trial. Also, it must be reproducible. So in other words, whoever you give this procedure to, they should be able to perform the exact same experiment as anybody else. Once your procedure has been written, it's time to collect all your materials and actually perform your experiment. As you complete it, you'll want to make sure you collect all the information in terms of observations and data that you can. Some labs might require you to perform qualitative observations. These would be describers, qualities. So, it feels hot. It looks like it's bubbling. It looks like it moved faster. Or some labs might require you to take quantitative data. These are numerical measurements with numbers and units, typically recorded in a data table. That data table must be done with a straight edge. You must have columns and rows for all of your data, and they must have labels so we know what exactly that we're looking at. Make sure there are units for all of your measurements, and includes all of the measurements you have actually taken. Once your data has been taken, it might not be enough to just include it in your lab. You might need to perform some analysis. This could include doing some calculations. If you do calculate, please show all your work. This means writing down your equations, substituting in values, and solving. If you do get answers, you should round them to the proper number of sig figs and label them with the correct units. If you need to graph your data, then you must make sure that you label your axes. You'll always want to give your graph a title labeled with the vertical versus horizontal axes, or in other words, dependent versus independent. The independent variable is going to go on the horizontal, the dependent goes on the vertical, always. Make sure that you use a nice scale for your actual graph itself so that your entire graph fits on the paper and starts at 0, 0. Make sure all the boxes on your axis are worth the same value. Finally, once you're done, you're going to be asked to make a conclusion. So, was the purpose of the lab met? Was your hypothesis supported? Did you find out what you set out to find out? If yes, then you need to support it with the data that you collected. If not, again, use the data you collected to discuss why your hypothesis or purpose was not supported. Finally, most labs include some sort of error. When you are citing error, you need to be very, very specific. Cite specific things that occurred within the lab. You cannot simply say there was human error or measurement error. You cannot say, I used the scale incorrectly. I used a meter stick incorrectly. These are not viable sources of error. If these errors in measurement do occur, you simply would have measured again. So again, we can't cite these as sources of error. You must cite specific other occurrences that happened within the lab that could have made it go awry. That's it. Good luck designing your own experiment, and thanks for viewing.